All right, I'm going to try to make this as simple as possible. I'm also not going to do the full notes. It does say to evaluate the 6 trigonometric functions for the real number. Use reference triangles. Each example, I'm only going to do 2 trig functions, just so this video isn't like an hour long. So with that, one of the things to keep in mind, on our unit circle, we put ordered pairs. Those ordered pairs, so we have x and y as ordered pairs, they actually connect to 2 of your trig functions, and actually really 4 and kind of all of them. But mostly that is your cosine of your angle and your sine of your angle. And like that's a direct connection. So if you're asked to find cosine of an angle, that is actually the x value. If you're asked to find sine of an angle, that is the y value. So with that, let's get started. Evaluate the 6 trig functions of the real number. Use reference triangles. So think of that as reference angles. So I'm going to draw 120 degrees. So if I know 180 is over here, I'm not going to go that full distance. So your reference angle is this space here. Remember, it always has to connect to the x-axis. So if we went 120 degrees, then your reference angle to get us 280 is 60 degrees. So if I have my triangle memorized, so across from 60 is square root of 3 over 2. Because I went left, this is negative 1/2. So I'm going to evaluate on this one. I'm going to do sine and cosecant. So instead of having to do like the whole opposite over hypotenuse for sine, if we connect that to our coordinate, sine is your y value. And remember, y is your up and down. So in this case, the height of that triangle. How high did we go here? Well, we went square root of 3 over 2. So now I can find cosecant because cosecant is the reciprocal or inverse of sine. So cosecant would be, if I flip that, 2 over square root of 3. Now we can't leave our answer like that. We need to rationalize it, meaning I need to multiply the top and bottom by square root of 3. Square root of 3. So on top we get 2 square root of 3. On bottom that becomes just 3. So that would be 2 of those trig functions. So on B, we have the angle 5 pi over 4. Now, some of us, I think, especially 6th hour, I did a really long explanation of finding reference angles. I'm sorry, it was terrible. So let me try to re-explain it. So we know this is 0, we know this is pi over 2, and we know this is pi. And this is 3 pi over 2. So if you, and then this is also 2 pi. If you can think about how many pi's are you making? So for example, if I have 5 pi over 4, well, 4 can go into 5 one full time. So there's 1 full pi in that. Plus, so I'm going to go 1 full pi. So that'd be here. We went over by 1 pi over 4, or pi over 4, which would be here. We haven't gone another full half, we've only gone a fourth. So that lands us in this quadrant here. So with that, your reference angle always has to connect to the x-axis. So in this case, it's how much did we go over? Well, we went over by pi over 4. So here's my triangle. Well, pi over 4 is really 45 degrees. So this side is negative square root of 2 over 2. Negative square root of 2 over 2. And then your hypotenuse is 1. Not super concerned about that. So in this case, I'm going to find cosine, and I'm just going to say of t, and its inverse secant of t. So we have cosine is your x value. So the x value is how much we are going to the left in this case. So cosine of t equals negative square root of 2 over 2. And then secant is the reciprocal. So if I flip that, I always keep the negative on top. Negative 2 over square root of 2. Once again, we can't have that in the denominator, so we rationalize it, square root of 2 over square root of 2. And we end up with negative 2 square root of 2 over 2. Oh, hey, those 2's actually can cancel. So this is really just negative square root of 2. So our next one so we have this negative 3 pi over 2. So if I go negative, that means I'm going left. Every time I hit here, I've gone half a pi. So there's 1/2 pi. There's 2/2 pi. That's 3/2 pi. So it actually lands us here. And that's something we didn't talk about with the unit circle, is what if we are on these axes? Well, let's think about it. The unit circle has a radius of 1. So from here to here, that is 1. So that ordered pair would be 0 in our x, 1 in our y. So if I am going to do tangent of theta and cotangent of theta, if I want to find tangent, well, this is where we are actually going to use our trig ratio. Sorry, not our trig ratio. One last connection from here. Tangent of theta actually equals sine over cosine, which means it equals your y value over your x value. So tangent of our angle, well, your y value is 1, your x value is 0, that is undefined. So, well, then our cotangent, the reciprocal, well, if we flip 0 over 1, that is 0. So, looking at the next page. The next page is just more practice. So I'm going to go through these a little bit more quickly. I'm still going to just do sine, cosine, tangent. So I think your homework might ask you to do all 6. Do all 6 if that's what it says. So tangent of negative 240. So that is going backwards. So this is negative 90, negative 180, and I land here. So we're trying to find this space. If this was negative 180, and we've gone this whole distance, which was negative 240. And remember, we actually will turn that into a positive for that reference angle. So with that, it's like we've gone over 180 by 60 degrees. So 60 degrees is our reference. We, across from the 60 is square root of 3 over 2. This is negative 1/2. I'm actually going to do cosine this time because I think we already did sine of 60. So cosine is our x value. So how much we went to the left. So cosine of our angle is negative 1/2. And then secant is its inverse. Would be, if I flip that, that's really just negative 2 over 1 or negative 2. All right. Next one. So here, if I think about how many full pies I've gone 1 full pie plus 5 over 6 pies more. So with that, here's 1 full pie, we should know this is 3 pi over 2. 5 pi over 6 is going to be bigger than that. It's going to land us here. So in this case, we're looking for this angle. And so I think of this as I'm really close to getting to making another pi. I'm pi over 6 away. I know this is 2 pi. But just kind of how I'm thinking through. Every time I hit the x-axis, I've gone pi. So if that reference angle is pi over 6, that is actually 30 degrees, making that conversion. And across from the 30 is negative 1/2 because we're going down. This side is square root of 3 over 2. And then I'm going to do sine on this one. So sine of t equals, sine is our y value, that's negative 1/2. And then cosecant is flipping it, which would be just negative 2. So hopefully this is like streamlining the process, making it a little bit easier, just making that connection between the x and the y, and also how far around you're going. All right, and our last one, this time I'll do tangent and cotangent. So we're negative, so we're going left. So if I break this apart, this is, I'm going to think of it in terms of positive. Just know that I'm going clockwise around. So that's a full pi plus 3/4 of a pi. So here we have 1 full negative pi because we went negative. And then 3/4 pi is a full half and a little bit more. So we fall here. So we're like trying to find this missing space. And we are pi over 4 away from having that another full pi. So there's our triangle. Pi over 4 is our 45, 45, 90. So square root of 2 over 2, square root of 2 over 2. So, which actually I think we kind of did, no, we didn't do that tangent. So tangent is your y over your x. So the square root of 2 over 2. Now we want to divide by a fraction, but we don't divide by fractions. We multiply by reciprocals. So I'm going to flip my other square root of 2 over 2. And those end up canceling to just 1, which if tangent's 1, well, the reciprocal of 1 is also just 1. So hopefully this is making a little bit more sense. Let me see. Okay, this is our last 3 examples, and then this is just asking you specifically like to find certain ones. So like instead of doing all 6 on the last ones, I picked which ones I wanted to find. You don't get to do that on your homework. But this now one specifically, what's cosine of 3 pi? And that's going to be a little bit more like what your test is set up like. Is I'm going to tell you find cosine of 3 pi. So cosine of 3 pi. So first I need to go 3 pi's. So start here. Here's 1 pi. Here's 2 pi. And I'm going to go around again. Here's 3 pi. So we land here. Well, remember the unit circle has a radius of 1. So this would be 1 to the left and 0. And cosine is your x value. So cosine of 3 pi equals negative 1. That's it. All right, and then sine. So negative 13 over 6. So there are 2 full pi's in that, plus, or I guess 2 full negative pi's if you want to think of that, plus another negative 1 pi over 6. Because 6 can go into 13 twice fully, and then it goes an extra 1/6 to get to that 13. So with that, when I draw my picture, that would be 2 full pi's, but to the left. So 1, 2, and then I just need to go a little bit more to that 1/6. So that would be like that. And my triangle is at overage. How much past did I go? I went pi over 6 past. And pi over 6 is 30 degrees. So across from the 30 is the negative 1/2. Square root of 3 over 2 is adjacent. Sine is our y value. So this is negative 1/2. Because that vertical up and down is the y value. All right, and then cosine. So I'll be looking for an x value this time, so left and right. And once again, I'm going some full pi's. So I like thinking of it just as positive. So I'm sorry I did negative on the last one. I'm just going to think positive. 3 can go into 6 2 times nicely. That would be, or sorry, 3 can go into 8 2 times nicely. That would be 6 plus 2 more pi over 3's. So 2 pi's plus 2 more pi's over 3. So with that, because it's negative, I gotta go to the left. So I'm gonna go 1 pi, 2 pi, and then 2/3 pi. So 2/3 pi is more than a half, but not quite another full pi. So that'll land us here. And this time I need this space that we didn't go to get to another pi. And that space was pi over 3. So that would be 60 degrees. Across from the 60 is the square root of 3 over 2, but it's negative because it's down. And then adjacent is our negative 1/2. And our x value is our left or right, which is that negative 1/2. So there is that answer. So I hope that made reference angles a little bit easier. And we'll probably have questions on Friday, so we will 100% start with questions that you guys have tomorrow. But give it your best shot, check the key, and then if you're really struggling, look up to see, can you find another video explaining it? Khan Academy is a great resource. or just YouTubing like how to evaluate trigonometric functions, and maybe they can explain it differently than me, and maybe that'll help. So have a good day. Thanks, guys.